vectors again. Okay, so let me start with another example. This is, I would call it level 1 problem for vectors. It's not hard, but I mean, you need to get used to vectorial way of thinking, yes? So let me write the problem for you first. ABCD is a square. ABCD. Let me draw, for example, the picture here. I will try to draw a square here for you. This is what I want to mention. This is a convention. You like when I say by convention, yes?
No.
We absolutely. It's clear from the photo that you made for me. So, it's by convention. When you say that ABCD, it means that you are not allowed to name it in this way. ABCD is wrong. This is not the way that you need to name the quadrilateral. You start from any point that you like, and then either to choose to go clockwise direction or anti-clockwise direction. That's up to you, but you need to respect the order. For example, I choose a point. I choose, for example, this point for A. Then I choose to go clockwise. The next one would be B. So then I have to respect what I have chosen so far. So this has to be C. This has to be D. Of course, in this case, I drew the picture for you in front of your eyes, but in principle, just writing is enough. ABCD is a square. Even if that's not a square, assume that this is a square. Okay, and prove that or show that AC, the vector AC, plus vector BD is equal to vector AD plus vector BC. Okay, so this is what I want to show. Let me close the door. You might think that this is wrong if you are thinking in terms of lengths. Let me try to explain why some of you might think this equality is wrong. If you think in terms of the length of these, yes, that is wrong. But this is not equality between the magnitudes. This is equality between vectors. You see, which one is vector AC? Vector AC is this diagonal vector, and BD is another diagonal vector. So I am saying that if you add these two vectors, it becomes equal to vector AD, which is this side, plus vector BC, which is this side. If you think in terms of the lengths of these, you might say this is wrong. How is that possible? Because we know that the diagonal of this square is bigger than the sides. But now you are saying that if I add these two diagonals, it becomes equal to the sum of two sides. The reason that you might think this is wrong because you are thinking from in terms of length points of view. This is not length. You see, I am not telling you that the length of AC plus the length of BD is equal to length of AD plus the length of BC. If I tell you to prove this, then immediately you say that this is not possible. This is wrong. Why? Because the length of AC, so let me draw AC for you here. This is the vector AC. If I ask you the length of AC, you take your ruler and you measure this length. And the length of BD, the vector BD is this vector. The length of this and the length of this are added, okay? And then I am saying that the length of AD, which is this vector AD, and the length of BC, which is this one. It is completely clear that this equality is wrong, yes? Do you feel it? Because I am adding these two, so you know that the length of a square is greater than this size. So this one is greater than this one.
This one is also greater than this one. So how is that possible? If I add these two, it becomes equal to these two. Yes, if you think in this way, you have this is correct. This is a wrong equality. But I haven't asked you this. I have asked you the equality between two vectors. This is first thing that I want you to understand. Do you really understand what's going on? Yes or no? Because I am not comparing the lengths. I am comparing the vectors themselves. Yes? Okay, so this is a level 1 problem. So it tells you that if I add this vector with that vector, with the method that we learned, you remember we need to parallel transport one of them and then draw this one and something like that. If I do this, then it becomes the sum of these two vectors if I obey the same rule. Okay, so this might be a little bit hard problem, I agree, but I want you to learn how to do this. First of all, you really need to do these parallel transports because it would be a little bit troublesome. So what I can do, so let us try to, when I write something, I want you to make sure that I understand this one. Okay, do you agree that instead of vector AC, I can write vector AD plus vector DC? Do you agree with this one or not? There are two ways to confirm this. One way is the Scholz method, yes? Do you agree? Because AD, these are the letters in between, they are the same, and I am adding them. So according to that rule that we learned why this is true last time, I can in my head eliminate these middle ones. What is left is AC. Is that right? This is one way of confirming this. Another way of confirming this is to refer to the picture itself. This is vector AD, and I am adding vector DC to it. You see, this is the standard way. AD, the next vector is being drawn from the tip of this one. You see, this is the standard way. Yes. So if I ask you what is AD plus DC, you would say that I will connect the initial point to the final point, and then I will put the tip of the arrow at the final point. So then what do you get? You get exactly AC. So you can confirm this equality in two ways, using the picture or using the Scholz rule, yes? Now, let me write something similar for BD. For BD, again, I can write BC plus CD. You might say that there are probably other ways to write this. I would say yes, but why I have chosen exactly this particular combination, the reason is that you need to have some experience to understand what to do. Yes, let me see. Let us be patient and wait why this will work. First of all, confirm that this equality is correct. Again, two methods, yes? I have the Scholz rule. These two letters are the same. I can eliminate them in my head, and what's left, B and D, so that's correct. If I refer to the picture, BC is from here to here, and then CD is from here to here. So it's clearly BD for the same reason, yes? But now, look, on the left-hand side, I want to have, so I would say that we know that, so the solution is like this. We know that I write these two. Then I would say the left-hand side, therefore, the left-hand side is equal to. Instead of AC, I am allowed to put this combination because I know that they are equal. So I take this away and put this one instead. Agree? And plus BD. The left-hand side, you see, the left-hand side is this expression. This is my left-hand side. Instead of AC, I took it away and put this one instead. After AC, I have plus, I put plus, and instead of BD, I take it away and put this one instead. Agree? But now, do you remember we talked about associativity and commutativity, yes? So if I want, I can take pair of brackets and put around any pair of them that I like. Even if I want, I can interchange them. No problem. So here I want to do that. By having an I on the right-hand side, you see this is a good way because AD, I need it on the right-hand side. BC is also needed. So it will motivate me to put them in one group. Yes. So I will put this equal. I put this pair of brackets, but I decide to take these two and put them next to each other. Plus BC. And then I have to deal with this one somehow, but then you realize what's happening. I put DC and CD in one pair of brackets. So I want you to understand step by step what's happening. Everybody happy with that? So do you follow the logic? Okay, now I hope that you know what's happening. We talked about this yesterday. I can use Scholz Rule. I can also say that these two vectors are opposite because one of them is CD, the other one is DC, so they are opposite. In any way, if I use the Scholz Rule, I would say C and C are gone, DD is left, but DD is 0, yes? So this is, in any way, this is the 0 vector. And then if I add the 0 vector to any vector, it will not change the result. It will remain the same. So it becomes equal to AD plus BC. And that is the right-hand side. So this is the way that we prove this for vectors. This is not telling you that the length of this one plus the length of this one is equal to that one. But you can conclude if you want. Let me ask you these questions to understand a little bit. So let me wait a little bit. Is there something that you don't understand here? There are two questions. How should I know to do this? This is another story. You need to solve some problems to get some experience. What I can tell you as a teacher is to explain the logic behind that. But if you say that, how should I know to do these things? You need to solve problems little by little, you will learn, okay? Is there any difficulty in understanding the logic that I am presenting here? Is that clear? Okay. So if I ask you, is this equality true or false? You realize that this is true. But now answer me. Is this equality true or false? Is this true or false? False? Yeah, it's true. True or false?
It's the same as the top of there.
No.
No?
It's not the same. Do you remember?
Oh, yeah.
I told you that A plus B magnitude in general is not equal to the magnitude of the first one plus the magnitude of the second one. Yes, do you remember? We talked about the donkey theorem. So it's always less than or equal to that one. So these are not the same thing. Be careful. Of course, coincidentally, they might be equal, but only under one circumstance. What is that one? Do you remember? When this happens, only in one case. You need to remember the pictures. It's easier to visualize than remember abstract things. So first of all, do you remember this one in general is smaller than this one? Let me just remind you. If I have this vector A and I have another vector B after that, if I add these two vectors, this becomes this vector. If I ask you, what is this one? You would say this is the length of this. And if I ask you, what is this one? You say that I measure the length of the first one, write it somewhere. I measure the length of the second one, write it somewhere, add these two numbers. So the right-hand side is the sum of the length of this plus the length of this. And the left-hand side is just the length of this, and that is the donkey theorem, yes? Donkey knows that this length is smaller than the sum of these two lengths, okay? But sometimes coincidentally, according to these two vectors, this might be true, but not always. This is not something that I can rely on it all the time. Unless, what happens? Do you remember the picture? Yes?
They're pointing in the same direction and parallel.
Parallel and pointing to the same direction. If means if and only if. A is parallel to B, and this is the meaning, this means and. A and B point to the same direction. Okay, I'm just reviewing something. This is what we covered. Okay, Now let us go back to my question. Based on what you see in this problem, so let me just categorize it in this way. Before even starting solving this problem, it was not hard to see this is wrong. Because I measured this one and measured this one, it is clear that these two are bigger than these two. Now I am saying that if I add these two lengths, it becomes the sum of these two smaller lengths, which is not correct. So you really don't need to do anything. You're just thinking a little bit. You realize that this is not true. Then I showed to you that this is indeed true, and this is the method. Now I am asking you another question. Is this one true or false?
True.
Yes, and the reason we came to this because Gustav told me that these are the same thing. I just want to review that they are not the same thing. Now I back to my old question. Are they? This is true or false?
False.
True or false?
False.
True or false?
False.
True. Yes. Come on. This one is equal to this one. It means this vector is equal to this vector. If two vectors are equal, what can I say about the lengths of those two vectors?
Equal.
They are equal. So you see, I told you that. If someone tells me the length of A is equal to length of B, can I conclude that, okay, the vectors are the same? Yes or no?
Yes.
Yes or no?
No.
No. Come on, guys. Do you really know vectors?
Kind
Yes.
of.
If the length of A is equal length of B, there is no reason that the vector of A. So let us repeat. When we say two vectors are equal, three properties simultaneously should be met. Yes? The first one, they have to be parallel. The second one, they have to point to the same direction. And the third one, they have the same lengths. Yes? In that case, I am allowed to say that A is equal to. This is just one single property. There are three conditions. This is one of them. One of them will not give me this one. For example, I don't know, if I take my ruler, assume that this is 10 centimeters, and I draw another vector 10 centimeters here, A and B. Is this true for these two vectors, assuming that they are 10 centimeters each?
Yes.
Yes. But are these two vectors the same?
No.
No. So you see, as soon as you see this equality, you are not allowed to conclude that these two vectors are the same. But what about the other way around? If someone tells me that I have seen two vectors, I guarantee you that these two vectors are equal. Can I conclude that the length of the first one is equal to the length of the second one?
Yes.
Yes. This is valid. This is not valid. Now, someone told me this is true. Yes, we showed that actually. So this means that the length of the left-hand side, which is this one, is equal to the length of this one, which is that one. Yes? Yes? Let me ask you, I think so if you are not very happy. So can you read this in English? How do you read it in English?
A vector over.
No. Read it in English. So might be this is the problem.
Line A.
No.
Line.
No. I don't want to say this is a vertical line A capped with arrow. No, not like that. What is this is red? Yes? The magnitude of the vector. And the reason that I am saying length, because I am practicing my English, saying length is very hard.
Length.
Even harder than that is if you want to have the plural form. Yes?
Lengths.
Length. Okay, so I don't know. Okay. So
Lengths.
so this is why. But magnitude is easy. Okay. So you read it, magnitude of the vector A. If you go to advanced mathematics, it's called norm of vector A. But I don't want to use that word. So norm of A, magnitude of A, or length. That's of course the norm, the magnitude, the length. Okay, the length of A. Okay, now read this one in English for me. Yes?
Magnitude of vector A plus vector B.
Exactly. So if I ask you, what is this creature at the end? Is it a number? Is it an object? What is this one? A is a vector at the end. So then this tells you, go and measure the length of that vector. That is the number that you need to put in front of this symbol. Is that understandable? Yes or no? So this means that the length. Okay, so now everything is clear. So that is one type of problems that you might face when you are dealing with this one. If you really have GeoGebra, we don't have very much time for those things, but if you really want to investigate it by measuring and everything, what does this mean? This means that if I add vector AC and vector BD by the method that I learned, how did I learn that? Let me parallel transport AC here. I don't know how can I do that, but yeah, something like this. Just I want to tell you the idea. Assume that I parallel transport it here. Yes. Oh, sorry, this is AC. And then I parallel transport BD, but from the tail of this one. Yes. What will happen? Something like this.
Yes.
This becomes, okay, so then this one comes here. So let me forget about the names. I parallel transport this one here. I parallel transport from this one from the tip of this one. And then I want to add them. What happens? It becomes this vector. Yes? So this vector that you see is the left-hand side vector. Okay? But let us do the right-hand side vector. AD is this vector. So let me parallel transport it here. And then BC is this vector. So let me parallel transport it here. And then if I connect this point to that point and put the arrow here, now this as a vector is equal to this as a vector. Yes. It means that they are parallel, pointing to the same direction and having the same lengths, yes? So if you want to prove what you have shown is this picture. Is that understandable? Okay. Hi. Now let me give you another geometric example, combination of geometry and vectors. So vectors are very, very important topic. So you don't lose anything if you spend time on it. Not for the Math 1C purpose, but for your future. Okay, so let me try to draw another picture here for you. I want to draw a rectangular cube here. So example.
Rectangular cube?
Yeah, because when you say cube, it means that the sides should be squares. But when you say rectangular cube, you are relaxing that condition. Okay, so let me see. Let me draw this one. Usually you draw a parallelogram because you need to have some this should be connected here, so then we can see this one. Okay, it should be a little bit longer, so that okay. So hopefully this is more or less clear what I am doing. So these dotted lines, it means that it is out of your sight. You cannot see them, it's inside. So this should also be inside. So let me give them names. I have given this a name A, D. This point inside, I call it O, and B, E, C, and finally this point X. Show that in this picture, this is a rectangular cube. Rectangular cube. Show that, number one, I want you to show that if I add vector FB to vector BE to vector CD, hopefully I have everything correct. Pardon?
You don't. Where's that?
Ah, yes, you are right. That's my bad. That's it. Is OC. And number two, I want you to also show that if I add OA plus OB plus OC, it becomes OX. So these kinds of questions are higher level questions in vectors. Yes?
Yeah, so if we get, I know we're not having them for this exam, but in the next exam, if we get a question like this, is it possible to like prove it by drawing, or do we have to use like?
No, by drawing doesn't work.
So we have to do it by the.
Yes, analytically.
Okay.
Yeah. But I want you to understand what does it mean drawingly when you prove something. So when I prove this one, I didn't use the drawing, but if someone asks me what does this mean geometrically, I was able to demonstrate it somehow, yes? So that's the mean. Okay, so here, usually, if I can use Scholz Rule, I will use that. Unless I cannot use it, then I refer to the picture to see what can I do. Okay. So, for example, let us concentrate on this one. Number 1. It's very easy. It's not hard, by the way. So, let me write the left-hand side. My goal is to show this one is equal to that one. And usually it is easier to start with that side, which is more involved. You shouldn't be that creative, because making this harder, so you see, this is simplified to this. Usually our brain is better to collect terms, to simplify things instead of making a mess, okay? But when you are a teenage, it's easier to make a mess usually. I don't know, how do you care about your room? Is it very tidy?
Yes, kind of.
Good. Kind of. Okay. By the way, being very organized is very good. I was listening to a US general. He was saying that when you wake up, the first thing you do, you need to make your bed, because you don't know what will happen.
Funny
What
joke.
will happen for you in that day. Might be that's a very bad day. You go outside and come back, you are tired. When you open your room, you see that at least my bed is made, and it is a relaxing feeling for you. Really, it's true. So try to be organized. It is not easy that much, but it is easy to start making yourself organized. Okay, so LHC, I will start from here. LHS, sorry. LHC is the name of an accelerator in Geneva. Yes, they are accelerating protons and smashing them together to see. Yes, I mistakenly said LHC, Large Hadron Collider. Okay. Okay. So here I have FB plus BE. I don't need to refer to the picture for this part at least, because that's the Scholz rule. Yes. So what is the answer? FE. Agree? But then I get stuck, because on the one hand, this is not the right-hand side yet. On the other hand, this is not Scholz rule. You understand? This is not Scholz rule, because there is nothing in common between them. But this is also not the right-hand side. It means that the problem hasn't finished yet. Then I have to refer to the picture. Where is FE? So FE starts from here. On the side of the wall, it goes to E, yes? So if you have, this is the front face of this cube, FE lies on this front face, yes? F to E. And then where is CD? CD is on the back here. This is your CD. So this tells you that if I add this vector to that vector, they are not starting from the same point. Actually, they are two lines in a space. If I want to show it to you, this is, for example, playing the role of this FE, and this CD is somewhere here. Yes? I'm claiming that if you add this vector to this vector, assume that this is the tip of the arrow and this is the tip of the arrow. I want to show that if I add this vector, which of course is longer, yes, they are of the same size, but I can make it a little bit bigger, I don't know. For example, yeah, something like this. This is the bigger one, this is the smaller one. I want to add these two together. Okay, so what should I do? There is only one way, parallel transport. Yes, there is only one way to add vectors, parallel transport them, okay? If you want, let me ask you, can you answer me this question? If I parallel transport this to the back side, what would be the name of that?
AC.
AC, exactly. Or if I can parallel transport this to the front side, what would be the name? EX. Agree?
Yeah.
So that would be the same. So it means that if you like, instead of FE, you can write AC. Okay? And if you like, instead of CD, you can write EX. It doesn't matter which one you choose. Is that understandable? Okay, so let us continue. So then, which one do you prefer? Let us see. If it doesn't work for one of them, I have to go back and redo it again.
EX.
Okay, so you are saying that, let me write this EX. Okay, so I keep FE the same, but you shouldn't play around. Put this one back and put this one in front. You need to, so because it doesn't work the problem, yes? So this one, FE, but instead of CD, you parallel transport it here, so it becomes EX. Agree? But then, do I need a picture for this part? If you want, yes, but there's no need for that. These E's are the same, so I can use the Scholz rule, yes? What's the answer? FX. You might say that I have done something wrong because this is supposed to be OC. But I am done, actually, because if you look at FX is this one. What is OC? OC is this line. Do you agree that these are just parallel transports of one of the other one? Yeah. So it means that I am done. So it means that this is equal to OC, and this is equal to the right hand side. Yes. So this kind of way of thinking, you need to get used to it when you work with vectors. It is very, very important. Is that understandable?
Yeah.
So when that's my advice. That's my experience. If you can use the Scholz rule, it's better to use it. And then when you get stuck, refer to the picture, try to find some relation between those. But there is only one rule. When I want to add vectors, I have to keep one of them, parallel transport the other one, so that I can combine them, okay? So it doesn't matter, are these in the plane, or one of them is in the plane and one of them is in the space? It doesn't matter. If I want to add them, I have to parallel transport them, yes? Is that clear? Okay. Now, what do you think about the second one? In the second one, I cannot even use one single Scholz rule, yes? Because don't get confused, even though O is in common, but these are left-hand letters in common. They have to be in the middle so that you can use the Scholz rule, okay? So, okay, tell me. What is your opinion about this?
It's very good.
Okay. Except for that?
It's my opinion.
What?
Yeah.
No, I'm not asking you your opinion about the problem. I'm asking you about the solution to the problem.
Oh, okay.
Yes.
Okay.
Any idea? So let me just make sure you know what is OA. So let me draw it with this red color. So let me clean this one because that was from the previous problem. We don't need it anymore. Yes, so let me clean that. Okay, and then this is your OA. This is your OB. This is your OC. And what is OX? OX is this vector. Do you see that if this is the rectangular box, OA is this one, OB is that one, OC is this one, and what is OX? OX is going from this corner to that corner up there. So that's if you want to imagine, yes? So we want to show that if I add these three vectors, it becomes vector OX. So how should I do that? So let me start the first thing. The left-hand side is equal to. Do you have a strategy for that? Yes?
So I say that OA is the same thing as FB with parallel transported.
Mm.
And
Not FB, BF. It's very important to respect the directions. Yes? You said OA and FB. Yes, do you see that they are not the same?
Yes.
OA is in this direction, FB is in the opposite direction. They are negative of each other.
then I think the whole thing would be wrong because I said that OB is can be substituted with BC.
OB with B.
Oh no, OB plus OC can be the same thing as BC because
No,
okay, no.
no.
Because if you add those two,
No, this is not the adding rule. This is not in a standard way. They are starting
it should
from the
be
same
that-
point.
Yeah.
This, yeah, you need to play around, but you need to understand. Can I say that OB plus OC is BC? No, be careful. Let me repeat this. This is the standard way. The second one should start from the last point. Yes? If I have this situation, this is not a still. Here, we don't need parallel transport. Do I need parallel transport to find the sum in this case? Yes, because they have the same initial point. If they have the same initial point, still I have to do it with parallel transport. Only in this scenario, I don't need parallel transport. Yes? And that is more or less understandable. If you forget about it, let me tell you something. Assume that I start from here, because you remember the first session I told you that displacement is a vector quantity. So I start from here, I go one step in this direction, and then I go 2 steps in this direction. I end up here. Okay? You see, I am going one after the other, then I will end there. But here, they have started from the same point. It needs a parallel transport. This is something that you need to have it in your mind. Doesn't need any parallel transport, this needs. So here, I cannot say OB plus OC is BC, because they have started from the same. Okay? So opinions about this? Yes?
Could you parallel transport OC to BE?
Let me see. OC to?
End of CB.
Yes. Good. Good. So let me see. You start. So you want to keep OA as it is. You want to keep OB as it is. But you are parallel transporting OC to the end of OB. OC can be parallel transported to BE. Agree?
Yeah.
So hopefully everyone agree that this is BE. Is that understandable?
Yeah.
So instead of OC, we wrote BE. But now momentarily I don't need the referring to the picture because I found the Scholz rule. Yeah. So what is this one? OA. This one and this one can be simplified. It becomes OE. Yes. It is better at least because instead of having 3 terms, I have 2 terms. So it is a little bit simpler. But the final step, what should I do? Can I use Scholz rule here?
No.
No, because they are sitting on the left-hand side. They should be in the middle. So what is the answer? You need to do another parallel transport, yes? Where is OA? OA is this one.
Oh.
And then I don't have any extra color, but this is OE, yes?
Yeah. Yes.
So we want to show that OA with OE will be OX.
Wait.
Yes?
Can you put OA into EX?
Exactly. This is one way, yes? So he is saying that I decided to parallel transport OA to this EX. Is that understandable? Take this OA, parallel transport it, it becomes EX. So this means that instead of OA, I can write EX plus OE. Is this a Scholz rule?
No.
Yeah, that's good, yes. Is it a Scholz rule? No.
No.
It is not in this case, but it can be because I can interchange them, yes? Instead of writing this one first, this one second, I can write this one first, that one second. No problem.
Ah.
Now it becomes the Scholz rule, yes? So it becomes OX. And then that's the right-hand side. INT. Yes.
Is there a rule that when the same letter is on the end of both vectors, you can use the Scholz rule?
No. The Scholz rule, you see, these are not God-given rules, okay?
Okay.
So what I'm saying that why this should be the case, if I ask you why this rule works, because you say that if I have 3 points, A, B, C, if I draw the vector AB, this would be this vector. If I draw the vector BC, it would be this vector.
Yeah.
Now remember, this is A, this is B, this is C. Let me clean them. I ask you to add these 2 vectors. What is your answer to the sum of these 2 vectors? I give you the pen to draw the vector A plus this vector plus that vector.
It's AC.
This is exactly this one. Now let me bring the names back. This becomes AC.
Yeah.
But let me change for example, let me tell you this. Let me tell you BA plus BC.
Yeah.
Let us see why this doesn't work for this situation. I have 3 points again. I have 3 points, A, B, and C. Yes? BA is this vector. And BC is that vector. But this have the same starting point. So if I ask you what is AB plus BC, can you say it is AC or is it CA?
No.
No, you have to do parallel transport.
I know.
So the Scholz rule is a reflection of the definition of the addition of vectors.
What I'm wondering is if it's a BA vector plus CB vector, then the B's are on the ends of the vectors.
Okay, so we can just do this one. BA plus CB, you mean?
Yeah.
No, again, let us check. BA is this one. Okay, yes, you are right. In that case, it will work. Because why? Because now you understand very good, thank you. So this becomes CB. Again, this is in that direction. Yes? The reason is that, yes, you think it in that way. If you want to memorize it, an extra formula, it's good. Yeah, it works. If this one and that one are the same, you can cancel them, but it is very important to remember you have to write CA. So you not only cancel them, but you need to remember to interchange them as well.
Yeah.
So I prefer not to do it in that way. I prefer, if somebody gives me this to calculate, I would say that I will write this one in this form first, this one second. Then I have my friend Scholz rule here, yes? I see that these are the same. I eliminate them in my head. What is left is CA. This is the way that I see the problem.
Okay.
Yes? But if you want to have a rule for yourself, that's also working. Cool? Yeah. Is that any question here? So you need to remember these things a little bit. Okay, so as I promised, I have to stop here because otherwise I have to teach a lot and a lot. Okay, so I will stop here. Let me see what is happening.
Vad har hänt i världen? Du höll du på med på SO då? På samhällskunskap.
Let me give you one example and then I will stop. This is a very, very simple one. I want to make sure that you understand everything. So, what do you think about this situation? I am asking you, what is A plus B plus C plus D plus, what is A, B, C, D, E, F? What is this one? 1 second. Finished, 0. Yes? It's easy to see. This is by the way, it's a very powerful method. So you see, A, all of them are coming after the other one. So no parallel transport is needed. Yes? I start from here, go here. The second vector is being drawn from the tip of the first one. The third vector is being drawn from the tip of the second one. The fourth one is being drawn from the tip of the third one. And it continues until you see that I end the same point. So how much I have been displaced? Assume that this is your home, you go, I don't know, to ICA, then you go to school, then you go where, and then you go back home. How much you have been displaced? Nothing, yes? So this is the main difference between the distance and displacement. Is the distance 0? No, because you can feel hungry. It means that you are using energy, okay? But displacement is 0. So there is a big difference between distance, which is a scalar quantity, and displacement, which is a vector quantity. Okay? So, and there is a very big difference, then you will learn in physics, if that's a moving particle, if I ask you what is the average velocity of this particle, then it is 0, because the displacement is 0, and that's crazy, yes? But if I ask you what's the average speed of this particle, I cannot answer it. It depends how fast this guy has actually traveled this trajectory. So, okay. So I will stop here. So this is very simple rule of thumb in your head. If you have some arrows one after the other, and they end at start the same point, end at the same point, the sum is always 0. It's easy. Yes? So I will stop here now. And I want you to start working on the exam. Yes, don't waste your time. No questions? Let me just end this stream. I don't know how many people are watching. I see the 3. I want to say goodbye to all of you, okay? If you are from our school, probably I can open the Zoom. If you have some questions, you can let me know. I go to Zoom now, okay?